So in section 8.2, we multiplied polynomials by a monomial. So it's just one term times a lot more terms. We used a lot of the distributive property. But, you guys have different brain rot and different slang than we did back when I was young. So I'm a millennial. You guys are Gen Z or maybe Gen Alpha. So the way I would compare foiling and the distributive property is I would say foiling is the distributive property on steroids, meaning it's that to the max, that times 10. Now you guys might say the distributive property is an average guy, but foiling is the OG. Or maybe I should say foiling is the sigma. That might be a better way to say it. But regardless, let's just remind ourselves of basic foiling. So this example shouldn't be something unfamiliar, but what we're doing, or maybe it is, we'll find out. So FOIL. FOIL is an acronym, meaning each letter stands for something. The F stands for first. So the FOIL process is used when we're multiplying a binomial, two terms, by a binomial, two terms. So if you look, there's 1, 2, 3, 4 terms total. 2 in this set of parentheses, 2 in this set of parentheses. Now when they say first, and I've got the little lines here to show you what they mean. So when they say the first, they're saying multiply the first term in each set of parentheses. So x times 2x is 2x squared. Then multiply the outer two terms together. In other words, if you look at this as a whole group of 4, these are the two on the outside of the list, the x and the 3. And x times 3 is 3x. Then I is for inner. You multiply the two that are on the inner part of the 4. So negative 2 times 2x is negative 4x. And finally, the last. So the last terms in each set of parentheses. In this case, the negative 2 and the positive 3 give you negative 6. So once you do all that multiplying, and you can see 2x squared, 3x, negative 4x, negative 6. We can combine these two because they're like terms. 3x minus 4x is negative 1x. Then the 2x squared stays as it is, and the negative 6 stays as it is. So we have FOILed, we have multiplied these two terms together and gotten 2x squared minus x minus 6. So the big idea here, foiling is a way to remember what to do, but when you're multiplying two different things together that are multiple terms, the point is that every term in the first set of parentheses should be multiplied by every term in the second set of parentheses. So if you look back, first and outer are where we take the first term in the first parentheses, multiply by the first term in the second parentheses, and we multiply the first term in the first parentheses by the second term. So the first and outer cover taking the first term and multiplying it by both things in the second set of parentheses. Inner and last make sure we take the second piece in the first set of parentheses and multiply it by both things in the other set of parentheses. So let's practice this now. So FOIL, first, outer, inner, last. First, outer, inner, last. So first, I multiply the first terms together. X times x is x squared. Outer, x times 2 is 2x. And just like with the distributive property, there's nothing mathematically required about you drawing these lines. I just find it easier to make sure I've covered everything and done everything I'm supposed to do if I draw those lines. But I also wanted to point out, this first part should look like the distributive property. I've got a term, and I'm showing myself multiplying it by both of the terms over here. Then we've got the second term, so the inner, 7 times x. The last, 7 times 2. And most of the time, not always, but most of the time, these two middle terms are going to be like terms you can combine. 2x plus 7x is 9x. And we have our final answer. So most of the time, not all the time, but most of the time, your first term and your last term are just going to stay the same. But the outer and the inner, you can combine. First, 2x times x. Outer, 2x times 3. Inner, negative 5 times x. And last, negative 5 times 3. Just like before, the first term and the last term are standalone, so they'll just stay as they are. But 6x minus 5x is 1x. So we get 2x squared plus x minus 15. That's the result of multiplying these two binomials together. Okay, number 3, same process. First, 8x squared, because we do 4 times 2 is 8. X times x is x squared. 4x times 3 is 12x. 4 times 3 is 12. We just keep the x. Inner, 7 times 2x is 14x. And last, 7 times 3 is 21. So we'll write 8x squared. 12 plus 14 is 26. And we leave the 21 as it is. Okay, now 1, 2, and 3 have very similar formats, and by that I mean they're all written the same way. Binomial times binomial. Now 4 is actually the same, solved the same way as we did these, but it's written differently because they're actually wanting us to multiply the same thing by the same thing. So this is something that's very important. When you see this, you've got to remember what squared really means. And I try to drive this home a lot because I think it's common. We just see the way things are written and we just learn the routine, but we forget what it really means. Sorry, what an inopportune time to yawn. So I would not leave this written this way. It's not that this is incorrect, but to actually simplify this, I think it's easier to remember, okay, squared means you multiply the thing by itself. So this is the same as saying 6x plus 3 times 6x plus 3. Now, I'll do this in just a moment so you can see the answer, but I want to make sure you understand a common mistake people make, even high school students, probably even college students. They'll see this and they'll say, oh, that just means I square the 6x and get 36x squared. I square the 3 and get 9. No, that is not what that means. This would be 6x squared plus 3 squared. That would be squaring each piece individually, but we're not doing that, so never interpret it that way. We're squaring this whole thing. This binomial is being multiplied by itself. And as you've now learned to do that, it requires foiling, not just multiplying the first term by itself and the last term by itself. This is basically skipping the outer and the inner part of the process. So 6x times 6x is 36x squared. 6x times 3 is 18x. That's the first and the outer. Then we do the inner. 3 times 6x is 18x. And last, 3 times 3 is 9. So 36x squared. 18x plus 18x is 36x. And the plus 9. So that is the correct answer. You see, when people incorrectly just square the two pieces individually, they miss that middle term completely, which makes this a wrong answer. The majority of what you will see looks like these right here. So there are two on the back that are more challenging, and you'll have some like that. But honestly, like for most of your time in high school math, you'll have to do this plenty of times. The ones on the back will show up every now and then maybe, but not commonly. This is what you really need to make sure you hone in on and understand. Okay, so on the back, you see it's multiplying a binomial, two pieces, by a trinomial. this doesn't have a special acronym like FOIL. This is why I wrote that thing where it says that every term in the first set of parentheses should be multiplied by every term in the second set of parentheses, because that's really what we need to focus on when we have more terms than just 2 and 2. So what I would recommend is you just draw lines like you had before. Say, all right, I know 2x needs to be multiplied by every term in here. So I do 2x times x squared. That gives me 2x cubed. 2x times 4x. That gives me 8x squared. And 2x times 5, which gives me 10x. So I've multiplied everything in this set of parentheses by the first term. I need to do the same with the second term. So 3 times x squared is 3x squared. 3 times 4x is 12x. And 3 times 5 is 15. So one thing I sometimes call the distributive property is the party rule. Or maybe I do that with the distributive property too. Did I just say that? Sorry, I might be repeating myself. Both FOIL and the distributive property could be called the party rules, because it's almost like the first group, either it's the group outside the parentheses or just the first set of parentheses, they're the new people coming into a party. The people in the second set of parentheses are already there. Well, when you walk in, it's polite for you to introduce yourself to everyone, not just one person. Introduce yourself to everyone. So that's our same idea here. 2x and 3 are both walking into this party where these 3 people are already there. So 2x should say hi to everybody, and so should the 3. But we're not quite finished. We do need to look for like terms. This is the only cubed term, so we'll just leave it as it is. We've got 2 squared terms. 8x squared and 3x squared makes 11x squared. 10x plus 12x gives me 22x. And this is the only constant, so it just stays as it is, plus 15. Now these do take a longer time, but if you understand the concept of everything in the first parenthesis gets multiplied by everything in the second parenthesis, I think you'll see that it's not too complicated. It is longer, but not too complicated. So let's practice that with this one, and then we'll be finished. But I'd encourage you to pause the video and try this one on your own, and then press play and watch me do it and see if you got it. First, I want to multiply everything by 3m squared. So it'd be 6m to the 4th, because I add 2 and 2. 3 times negative 5m, or 3m squared times negative 5m is negative 15. M cubed, because it's 2 plus the understood 1. And then 3m squared times negative 7 is negative 21 m squared. So we've got everything multiplied by the first term. Now everything multiplied by the second term. 2 times 2m squared is 4m squared. 2 times negative 5m is negative 10m. And then 2 times negative 7 is negative 14. So double check your signs. It's always good to make sure you didn't make a mistake there. Then you can combine like terms. Now this time, this is the only 1 to the 4th, so it stays as it is. This is the only 1 cubed, so it also stays as it is. But we do have 2 terms that are squared. Negative 21 plus 4 is negative 17. And then this is the only square with just m to the first. Only term with just m to the first. So we just leave it as it is. And this is the only constant, so we leave it just as it is.